about space technology. We have discussed what are orbits, we discussed about the factors about the orbits, we discussed about various different applications based on these kind of orbits, right? So we discussed all these parts. Now we are entering the next part of our discussion, and in this section we are going to discuss about various kinds of satellites that India has. And all these are the satellites, the way the classification has been done by Indian Space Research Organization, ISRO. So let's try to understand what are the various application areas and how do we classify all the various kinds of satellites that India has. So first of all, just look at the various ways in which we can look at the applications of satellites. We have communication satellites, we have Earth observation satellites, we have navigation satellites, satellites related to space science, experimental satellites, small satellites, and university or academic institute satellites. So these are the various ways in which we define the different kinds of satellites that are in India. So let's have a look at them one by one. First of all, we have the communication satellites. Already we have discussed a few things about communication satellites. We discussed what? We discussed that they are located in the high Earth orbit at a height of 35,786 kilometers. Now, apart from that, what we know about communication satellites are they are very essential to the development of a country. If you understand India, if you look at the ways it has brought some significant changes, a kind of revolution, if you can say, in the communication sector, it all has been because of the communication satellites that we have been launching early 1980s. So the communication satellites have changed everything for us. For example, if you talk about telephones today, mobile phones, television, radio, all these have been made possible because of the communication satellites. Even things like tele-education or telemedicine, these have been some of the very significant ways in which satellite communication has helped India. So if you look at various kinds of applications, it supports telecommunication, television broadcasting, satellite news gathering, societal applications, weather forecasting, disaster warning, and search and rescue operation service. So all these are various application areas when it comes to communication satellites. Examples, if I have to take examples of communication satellites in India, we have two names, one the INSAT series and one the GSAT series. We don't see any INSAT series satellites launched anymore. It has been discontinued since the time GSAT series satellites came into the picture. So now you'll see that various GSAT satellites are launched. Every year there is at least one launch of GSAT satellites. And whenever it comes to any GSAT satellite, just remember this, that it is related to communication satellites. So again, this is one thing that will directly help you in your prelims examination as well. Because if you see a name and if there are various applications written about this particular satellite, you should understand what satellite can be used for what purpose. So if it is about a GSAT satellite, the first clue that you have is the fact that it has to be a communication satellite. Second fact, it must be launched to a high Earth orbit. So let's say a prelims question says, recently GSAT 19 satellite was launched. It was launched to a height of 2,000 kilometers. Or let's say it was launched to a height of 1,000 kilometers, 1,200 kilometers. It will be completely wrong. Why? Because communication satellites go to high Earth orbit. So it's not possible that a GSAT satellite has been launched to a lower orbit. So very easily you will be able to mark this option as correct or incorrect. Similarly, you know the applications. If it is a GSAT, it definitely means that it should be related to something in the field of communication. So if they say that recently a GSAT satellite was launched, and this GSAT satellite was launched for what? It was launched for mineral exploration, agricultural purposes, cartography, mineralogy. It will be wrong. Why? Because this must be an application related to communication. So this is something that you have to take as hints when it comes to the question paper as well. So communication satellites, we have INSAT series satellites and the GSAT series satellites. Now when it comes to the different kinds of communication satellites, there are frequency bands into which they are divided. We'll learn more about the frequency bands, etc. when we go to the chapter of IT and communication. There we'll have a better idea about it. But currently, I just need you to understand that there are various bands when it comes to communication channels. These are called as frequency bands, depending on the different frequency of the electromagnetic waves. So you have the L band, you have the S band, you have the C band, and then you have the X band, KU band, and KA band. All these are the different frequency bands. Depending on the application related to communication which is being used, these all bands are allocated to different types of satellites. For example, if you start with L band is something that is used by GPS. It is used by global positioning system. Similarly, S band, weather radars, surface ship radars, and some communication satellites are using S band. Then you have the C band. C band is usually used for television networks. Similarly, if you come to the X band is something which is used mainly for military purpose or defense. Then you have the KU band. When it comes to the KU band, this is something that is used normally for satellite communications, especially when it comes to television broadcast. So in television broadcast, you'll see that KU band is very widely used. Then after that, we have the KA band. KA band is used for satellite communications. At the same time, it can also be used to provide internet because it has larger frequency. It is able to transmit higher amount of data. Similarly, it is also used for some of the military applications as well. So these are various applications of the various frequency bands that we have. We'll learn more about it when we go to the chapter of IT and communication. Now the next application area that we have is Earth observation. We discussed this already that these satellites are also called as remote sensing satellites. Correct? These will be launched where? These will be launched to low Earth orbit. Right? We discussed all these. So examples in Indian context, we have Cartosat series satellites, OceanSat series satellites, ResourceSat. You can take the name of ReSat. Then HISIS satellite was launched. So all these satellites are examples of Earth observation satellites or remote sensing satellites. What are the application areas? We had already seen the list of application areas. It can be used for urban development, for rural development, for agriculture, for mineral related things, for disaster management, for cartography, for the study of climate change, related to climate change and the environment. All these are various application areas which can be done with the help of Earth observation satellites. Then we have the next application, and that is navigation. So in case of navigation also, we have two important satellites. One is Gagan and second one is Navig. We discussed the application of Gagan and we discussed the application of Navig. So we know that all these are the satellites in the Indian context which have been launched for navigation purpose. Now, next we have satellites which are meant for space science. For example, you have Astrosat and you have Mangalyaan. So Astrosat, Mangalyaan, you can add to the list Chandrayaan 1 and Chandrayaan 2, and the upcoming Aditya L1 can also be seen in the same list. So all these satellites that have been launched for space science application, they have not been launched for something that is related to the development of India or something that is related to the national development altogether. Right? So these are for space science and exploration. Then we have the next set of satellites which are experimental satellites. Here we have examples of INS-1A, INS-1B, INS-1C, etc. So when it comes to this set of satellites, what does INS stand for? INS stands for ISRO Nano Satellite. So this is a particular program that has been very recently launched by ISRO. 2017 was when they started with this particular program. Now this program has a very specific purpose. It has been launched so that anything that is experimental in nature, for example, they want to test out a component, they want to test out a sensor, something that is going to be launched in an upcoming mission. So they don't want that an entire mission is launched for just an experiment. So what can be done is that these nano satellites, small satellites, can be launched along with a particular launch that is being done by ISRO. For example, when the first two satellites INS-1A and INS-1B was launched back in 2017, there were a total of 104 satellites that were launched then. Out of these 104 satellites, 103 satellites were very small satellites called as nano satellites. So INS-1A and INS-1B were also launched in the same. So that has become a part of the experimental satellites that we have been launching since then. So a host of small satellites mainly for experimental purposes. These experiments include remote sensing, atmospheric studies, payload development, orbit control, recovery technology, and anything related to something which is just a component, which is just a small part of a big experiment or a big upcoming launch. All these will come as a part of INS. So this is about experimental satellites. Then we have small satellites. Small satellites are the satellites which are, you can say, sub 500 kg range, meaning the satellites which weigh less than 500 kgs. Here we have a lot of satellites. You have satellites which can be called as mini satellites. Then you have satellites which are called as micro satellites. Then you also have satellites which we just discussed, nano satellites. We also have satellites which are called as pico satellites. So how do we define all these? Basically, you'll see that most of the times when we are talking about small satellites which are less than 500 kgs, then in that case, this distinction happens something like this. Mini satellites will be the ones which are in the range of 100 kgs to 500 kg. Then you have the microsatellite. Normally, you would say that the satellites which are in the range of 10 to 100 kg would be called as microsatellites. Then the satellites which are in the range of 1 to 10 kgs will be called as nanosatellites, and the picosatellites will be the ones which are in the range of 0.1 to 1 kg. That is between 100 grams to 1 kg. Even then, let's say if there is a satellite which is less than 100 grams, something which is less than 0.1 kg or less than 100 grams, these are the ones which are also called as femto satellites. These are also called as femto satellites. So all these are various nomenclatures that have been given for all the different kinds of small satellites. But usually you will see that even if it's a 15 kilogram satellite or a 20 kilogram satellite, for all these different satellites, we generally tend to use the word nanosatellite. So when we say that nanosatellite market is booming currently, we basically are talking about the satellites which are of the range of, let's say, 20 kgs, 15 kg, even 5 kg, 10 kg, etc. So usual definition will tell you that this is how we classify the different kinds of satellites. But at the same time, even if it's a 15 or 20 kilogram satellite, we normally don't use the word microsatellite, but rather you'll see that the word nanosatellite has been more popularized for these kinds of satellites. So this has been observed. Now, examples in India that we have are satellites like SARAL or USAT. Even INS we discussed, INS can also come in here. So all these are the satellites which are small satellites, and that's why there is a completely different set of ways in which we are defining them. Now, one thing when it comes to small satellites, which is very, very important for you to know, is the market of nanosatellites. The market of nanosatellites has currently been booming. And if you observe, there is a very special distinction that you'll see in the market before 2014 and after 2014. If you look at the data up to 2014, you'll see that a total of only 75 nanosatellites were launched until 2014. All over the world. Today, if you look at the number of nanosatellites that are being launched, it's way beyond this number. So all the satellites included until 2014, only 75. Compare this to February 2017, India, PSLV C-37. With PSLV C-37, we launched a total of 104 satellites. We just discussed this. Out of these 104 satellites, 103 satellites were nanosatellites. So there was only one satellite which weighed like a normal satellite, normal remote sensing satellite. It was a Cartosat series satellite. And all the other satellites, total of 103 satellites in that launch, were nanosatellites. So that's why we have seen that nanosatellites as a market has grown a lot. A small application today, the companies, agencies, governments, they don't want to launch a big satellite. They don't want to spend a lot. They don't want to spend a lot, both in terms of money as well as in terms of time. They want that these things happen quickly, and for that they ensure that nanosatellites are being launched. So that's why you'll see that this is something which is also called as miniaturization of technology. This is something which is also called as miniaturization of technology, which has been happening in the field of satellites, and this has been widely observed in the field of nanosatellites. So that's why the market of nanosatellite, the use of nanosatellite, how it has changed the world over. All these are things which are also important from the mains perspective as well, because there are a lot of emphasis that is being put on nanosatellites. A complete separate program being launched by ISRO is one of the examples of the same. So this is about small satellites. Then we also have university or academic institute satellites. Here you have examples like Swayam or Pratham. All these are examples of satellites which have been launched by a university or by an academic institute. Now what happens is, for these kind of launches, ISRO also gives a lot of space and time to students or researchers or academicians who are coming in the field of satellites, because they want more and more people to participate. They want more and more people to be involved, because if more students are involved, if more academicians are involved, then in the future they will be the ones who would come back, and they would be the ones who may be interested in the field of space technology, and that is something that will carry forward India, carry forward the scientific temperament in India. So to build all that, to make sure that students are interested, more participation is coming from the academic field, what ISRO does is that wherever these kind of launches have to happen, ISRO will provide them the infrastructure, ISRO will provide them with monetary support, so that they don't have to think about these kind of issues, they don't have to think of running out of budget or not having any scope whatsoever to launch their own satellites. So if the students are trying, if the academic field is interested, then ISRO has been supporting them. So that has again been a very big step that has been taken by the Indian scientific field. So all these satellites are called as university or academic institute satellites. So these are the various kinds of satellites that we have in India based on the different applications. So we have discussed the applications on the basis of various kinds of orbits. We discussed all the areas which were important, and then we are looking at all the different kinds of satellites. So when you are in your examination hall, in the prelims examination, the questions might be easier, but when it comes to the mains examination, you have to combine all these information. So let's look at a couple of questions that can come from whatever we have discussed until now. Question number 1: why is Indian regional navigation satellite system needed? How does it help in navigation? This is a question that had come in 2019 mains examination. A straightforward question based on whatever we have discussed till now. You can very easily answer it. Second question: what do you understand by standard positioning system and protection positioning system in the GPS era? Discuss the advantages India perceives from its ambitious IRNSS program employing just 7 satellites. So this is a question that had come back in 2015. This was a 2015 mains question. And then you have another question: discuss the role of space technology in helping Indian agriculture or in helping Indian farmers.
Hello guys, my new vlog. Please to channel my Sakrapara. Sakrapara. Sukrapa. Sacrifice.